Hello everyone and welcome. This is the CyberSecStudy CISSP video bootcamp series. You're watching the free version of this domain. For access to the full version, go to the website at www.cybersecstudy.com. So hello everyone again, my name is Donald Parker. The reason you're watching this video is because you're interested in obtaining the CISSP certification, and in some cases you need it, right, for your job. The reason I'm here is because I developed a training program that can help you get past this doggone exam. So the program consists of a book of the course material, audio recordings of all of that content in the book. We have the video recordings now of all of the content of all 8 domains. I developed a Jeopardy style game that has questions that are based from the course material, and then a Kahoot competition style game where folks can compete and test their knowledge of the information in the course material. So this is a copy of the book. It's a little thicker than I really wanted it to be. But this is a hard copy version of the course material. If you purchase the audio or the video, then I'll also give you a soft copy of this course material. So for the book, it took me several years to write this book. I used several sources. The common body of knowledge, of course, the CBK is the most authoritative source. I also used the late great Sean Harris's all-in-one study guide. It's a phenomenal book. I used several practice question exam books that had explanations, very good explanations of key terms and concepts, and then the internet, of course. So I went through all these sources. I tried to group together the smallest grouping of terms that I thought would help you pass the exam. So I tried to, I categorized all these terms into either just terms, informational notes, concepts, and something I call muscle memory, which is all those algorithms and the OSI model and the ports and protocols and all that stuff that's just muscle memory that we have to memorize. I broke that out separately so that you could print out those muscle memory charts and focus on the muscle memory separate from understanding the terms and the concepts that I want you to know. So the focus of my book, of this course material, is to identify key terms and to expose you to those key terms in many different ways. I went through a couple of boot camps myself. I've taught boot camps with other people's course material, and what I've felt from those classes is that they were just throwing a bunch of information at you, just a ton of information. There's no way any of that stuff was sticking. So the intent of my program is to identify key terms so that when you're taking that exam and you're reading a test question, you see 3 or 4 key words, and those will point you to the correct answer. So we go through, as you go through this video series, you'll see these and hear these key terms. When we play rounds of Jeopardy, they're focused on these key terms. And when you test your knowledge with Kahoot, you're going to see these key terms again. So multiple times you're seeing these key terms and they're just embedded in your brain. So you could purchase the book, read the book. You could listen to the audio, which is just a verbatim, word for word illustration of the book. You can read or listen to the audio and follow along in the book at the same time. You could purchase the video series that you're looking at now, the full version of the video series for all 8 domains, which is the video recordings are a recording of a boot camp we just finished a couple of weeks ago. It turned out a lot better than I expected, and I think it can be really helpful. You could also watch or compete in rounds of Jeopardy, which, after you've gone through all the material and you're ready to see where you're at and test your knowledge, there are 15 rounds of Jeopardy to get through all 8 domains. But then Kahoot. Kahoot is something that we do on a weekly basis in the evenings. You could, if you go to the website and purchase the ability to compete in one of these competitions, there's one for each domain. The number of questions varies, but after you compete in this competition against other people who are preparing for the exam, it gives me a spreadsheet of every question and every answer, whether you answered wrong or right, so that I can sit down with you and know where you're weak and where you're strong. The people who compete well at Kahoot pass the exam the first time, every time. So the question that I often get, I think I get more often than any other question is, what's my success rate? How many of my students actually pass the exam? So I've been teaching CISSP boot camps with my own material for about 5 or 6 years. I've been teaching the boot camp for over 10 years, but all of my students pass the exam. If you go through my entire boot camp, I can tell you with the Kahoot rounds and the printout, the spreadsheet that comes out of that, I can tell you whether I think you're ready or not. If you're ready, you take the exam, those people pass every time. If you're not ready, I'll tell you, and I'll tell you what I think you need to work on. Now, I've had some folks who took the exam anyway, even after I told them that I think we need more time. They didn't pass the first time. I worked with them some more afterwards, and they passed the second time. So really, it's up to you. If you can get through all of this content, it's a marathon of material to get through. If you really want it, if you really need it, then if you can get through all of this content, I am very confident that you can get through the first time. But I would need to see you compete on Kahoot rounds in order to know for sure whether I think you're ready. All right, guys, that's it. Welcome to the program. Welcome to this journey to cybersecurity. It is the fastest growing industry in the world. It's the most exciting, in my opinion. I love what I do. I love working with this stuff. I love talking about it. I love sharing information. So again, if you're interested in the full version, go to www.cybersecstudy.com and take care.
So, domain number 8, the pièce de résistance, last of the Mohicans, security in the system development lifecycle. Most people refer to it as software development lifecycle, but software is a system, so you can encompass everything, software and systems, hardware, operating systems, or whatever, by saying system development lifecycle. So again, we don't have to be software developers to do well, to know what we need to know as cybersecurity practitioners. I started out my career as a software developer. I can write some scripts now, but I can't write any programs anymore. I'd like to get back into it, and eventually will, but I just manage a team of software developers who were doing, vulnerability scans and reviewing source code. And I didn't need to know how to code in order to make sure that they were following consistent, secure processes, especially with respect to analyzing the risk. Those tools identified vulnerabilities, and then I helped develop the methodology for assigning threats to those vulnerabilities and then assessing the likelihood versus the impact of a threat overcoming a vulnerability. A machine code is also referred to as object code. Those old computers use punch cards. All they knew was, zeros and ones. The oldest computers had switches, buttons and switches that you would use to program them. A machine code is also referred to as object code. Represents the actual bits and bytes that are executed by the computer CPU. This is what the computer understands, zeros and ones. Source code is human readable program instructions in their original form. To execute the program, source code must be translated or converted into machine/object code, which the computer understands. And then you can have open source and closed source. There's a big debate about whether open source is better than closed source, which one is more secure. Open source, you've got a lot of Linux operating systems that are open source. Microsoft, of course, would be considered one of those that's closed source. But the debate centers around, if you make the source code available, if you make it open source, then a lot of different software developers can see that source code. Think of Bitcoin. The source code for Bitcoin is open source. Idea meaning that you have a lot of developers looking at it. You'll have the potential for a lot of folks to be able to identify vulnerabilities in the code or weaknesses in the code, and then hence make it more secure. But then closed source folks say, well, if you don't let people see the source code, they won't have a chance to see the vulnerabilities, and that makes it more secure. But they're still getting hacked, even if they're closed source. Vulnerabilities are still being identified. How easy you make it for them is relative, but a lot of folks are on the fence with that one. So bytecode is also known as pseudocode, spelled with a P-S-E-U-D-O, pseudo. If you want to pronounce it, I pronounce it that way in my head so that I can remember. Pseudo is also referred to as P code. So bytecode is an outline of a program written in a form that can easily be converted into real programming statements. Unlike human readable source code, bytecode are compact numeric codes that are closer to machine/object code than they are source code. Then mobile code, whenever I ask this question, I get a lot of folks that say it's code that's mobile, that can be moved from one platform to another. But that's not it, essentially. Mobile code is software transfer between systems, usually across a network, and executed. The key point here is that it's executed on a local system without explicit installation or executed by the recipient. So the owner of the system or the user of the system doesn't allow this code to run or install something on their system. And often it's done without them knowing it. So mobile code, you go to a website and you've got Java or ActiveX or something that installs something, makes something happen on your system without requiring you to allow it to happen. So Java applets, ActiveX, Flash, animation, macros embedded within Microsoft Office documents. These are all examples. In almost all uses of mobile code, the user is not aware that the code is downloading and executing on their workstation. And we'll talk about the difference between Java and ActiveX and how the security mechanisms that they have. That's important to know. Assembly language is a low-level programming language in which each statement corresponds to a single machine code instruction. So we'll talk about why this is a low-level language. Each assembly language is specific to a particular computer architecture or platform, whereas with high-level programming languages, they're portable across multiple computer platforms and architecture. So low-level languages, high-level languages. Low-level languages are, they're specific to a particular computer architecture. They don't have very human-readable source code that is then converted into machine code. Higher-level languages, we're trying to get to the point where we're developing software with human-readable statements, and of course, they're portable across multiple platforms. So compiled languages, when we have source code that has to be converted to machine code, there's two ways of doing it. You can compile it from source code to machine code / object code, or you can interpret it from source code to machine / object code. Compiled languages are written in near human readable source code and then compiled into machine code. All of the source code is written before a compiler converts it to machine code. With interpreted languages, the source code is converted to machine code on the fly as the source code instructions are being written, and interpreted programs must be reduced to machine instructions at runtime, which makes them slower than compiled languages. That's an important comment to remember.
Hey Don, which one is on the fly?
Interpreted languages, machine instructions. It reduces interpreted. Source code is interpreted to machine code on the fly at runtime, which makes it slower. Interpreted languages are slower than compiled languages. That could be a question. I can't tell you guys what questions you might see on the exam, but I can tell you what I think you might see in practice questions, right? What I think is important for you to remember. All right, so these programming languages, the different generations, we're in these generations, we're going from low-level programming languages to high-level languages. So first generation language is machine-level programming language. There were no instructions written in human-readable form and then translated into computer-readable form. The programming instructions were entered through the front panel of the computer system with switches and push buttons. They actually have examples of some of these computers in DISA. When you walk into DISA headquarters, they have a showcase as you're walking in through the front entrance with some of these older computers. I haven't made my way to the CyberSecurity Museum in I think it's near Laurel, Maryland, but I need to go there sometime. Second generation languages are usually low-level assembly languages in which short human readable statements are converted into computer readable statements. Each statement corresponds to a single machine language instruction, like we said about assembly languages. It's specific to certain computer architecture, unlike high-level languages, and we talked about this already with assembly languages. Third generation programming languages tried to make the languages more programmer friendly by allowing them to write source code that was more human readable. Third generation programming languages are considered the first high level language. First generation languages, buttons and switches, no source code. Second generation languages, we're starting to get the source code, but it's assembly language, assembly level language. It's not very human, just short little statements. Programs aren't very portable. Third generation is the first high level language where we have source code and the programs are portable across multiple platforms. Some examples include COBOL, Fortran, BASIC. The fourth generation programming languages followed the third generation's upward trend towards more human readable source code. Fourth generation languages were designed to reduce the programming effort, the time that it takes to develop software, and the cost of software development. And examples include SQL and Code Fusion. I sent my kids to software development STEM program, and they, everything's drag and drop. You want to put something here on a page, you don't have to write the code to make it appear there. You just drag and drop it, and the code is automatically written for you. All right, so with generations 1 through 4, programmers were trying to tell the computer exactly what to do and exactly what not to do. And if they didn't get it right, if they told it what to do but not exactly what not to do, or if they didn't tell it exactly what to do and how to respond to a situation that they didn't consider, then you could have a lot of crazy things happen, a lot of vulnerabilities, a lot of weaknesses. Fifth Fifth generation programming languages are based on solving problems using constraints given to the programs rather than using an algorithm written by a programmer. So we're trying to get to the point where these high-level languages, where we're making it easy for software developers, we're trying to use more human-readable statements. We get to fifth generation languages, it's more object-oriented, where we're not writing if-then statements to tell a computer what to do and what not to do. We're identifying the information that application is developed to manage. We're categorizing or classifying those pieces of information, writing attributes about them, writing statements of what those different things can do. And we'll go into this a little more detail in just a minute, but fifth generation programming languages, we're getting more into object oriented, where our focus is on defining the different types of information and characteristics about them, and then writing short statements to manipulate the objects or the information contained in those objects, rather than writing a bunch of algorithms and if-then statements to tell a computer what to do and what not to do. So object-oriented programming is a fifth generation language. It's an approach to problem solving where all computations are carried out using objects. So an object-oriented programming language may be viewed as a collection of interacting objects, as opposed to the conventional model in which a program was seen as a list of tasks to perform, if-then statements. In object-oriented programming, each object is capable of receiving messages, processing data, and sending messages to other objects. Object-oriented programming is a programming language model organized around objects rather than actions, and the data rather than logic. So with older generation languages, the programmer's challenge was seen as how to write the logic and not how to define the data. So object-oriented programming suggests that what we really care about are the objects we want to manipulate rather than the logic required to manipulate them. All right, so some of the components of object-oriented programming that we need to be familiar with. Object is the most important category here, but actually class is bigger than an object. You could have a class of objects. So you could have a class for transportation, and then you can have an object for plane, object for trains, object for automobiles. And in those objects, let's say the automobile object, you'd identify different types of automobiles, sports cars, sedans, any attribute that you want to have that application is going to focus on. You're going to identify all these objects, identify characteristics about them, but then also you're going to identify what functionality. So in a car, it can accelerate forward, it can decelerate, it can turn left, it can turn right. You're going to identify all these things that the object can do. All right, so an object is a component of a program that knows how to perform certain actions and how to interact with other elements of a program. Objects can interact with each other in a program to make something happen. Objects are the basic unit of object-oriented programming. We've already talked about that. So a class is a blueprint of an object. If a class were a concept, an object would be an embodiment of that class. So I already talked about the difference between that. You have the class is a bigger thing, and then you can have objects underneath that. A method in object-oriented programming is a procedure associated with the class. A method defines the behavior of the objects that were created from a class. So we could have a class of objects. The objects within there, we said cars, planes, all the different things that those objects can do are the methods. So the acceleration, the turning left, the turning right, all those things are methods with the automobile object. And then inheritance is a way to reuse the code of existing objects. Inheritance comes into place when subclasses of data objects share some or all of the main class's characteristics. So if you've got a class of transportation, we've got objects in there, let's say trains and automobiles are two separate objects. They both accelerate and decelerate. So, the code that you write, you'd only write that code once and then inherit it from other objects can inherit that code. No sense in rewriting it, especially if it's similar. All right, Aaron does it again. Aaron does it again. Congratulations.